So remember the Jacobian method that we used, basically in order to find the PDF of functions y1, y2 of functions of x1, x2, then basically the PDF of y1, y2 will be the PDF of x2 multiplied by the Jacobian, okay, or divided by the inverse of the Jacobian, where basically x1 and x2 will be the inverse functions, basically. Okay. Now, one scenario, sometimes we have two functions, sometimes we have only y, which is equal of a function of x1 and x2. We can use the same method by applying the Jacobian to simplify the problem. So this is one example that I would like to give you. So for example, here we have two random variables, x and y, having the joint PDF given by this. The PDF is given by basically 24 e to minus 4x plus 2y for the values from 0 less than y or equal to y less than or equal to x less than or equal to. Okay. Now the yeah, sure. So basically, and we are interested in the function z, which is equal to function. And here we have only one variable, which is the function of two variables. So in total, we have 3 random variables. We know the joint PDF of x and y, and we are finding the PDF of z. So one way to use the very systematic way of the Jacobian is to define a new random variable y, sorry, w, which is equal to y. So w will be defined as y, and z will be defined as 5x minus 1. So now we have two functions, two new random variables that are functions of two random variables. Z is a function of x and y, w is a function of x and y, however there's 0 x. Now we can apply the same concept. So here is where we have basically found the inverse functions. So basically w equal y means y equal w, and z equal 5x minus y means x equal z plus w minus divided by 5. Okay, now we find the Jacobian. The Jacobian is a derivative of the function with respect to x, derivative of the function with respect to y, and derivative of the second function with respect to x, derivative of the second function with respect to y. So basically the rows are the first function, the second row is the second function. Right? And then now derivative of z with respect to 5 is 5, clearly. Derivative of z with respect to y is minus 1. Derivative of w with respect to x is 0, because it's not a function. And derivative of w with respect to y is 1. So taking the determinant of this, 5 minus 0 by minus 1 gives you 5. So now we can write the joint PDF of z and w equals the joint PDF of x and y evaluated at the inverse functions. What was the inverse function of the vector? X was zw, z plus w over 5, and y was y was equal to w. So now we substitute x and y as z plus w over 5 and w. So if we go back to the original PDF, this is x, so we have 4x. We substitute z plus w over 5 with instead of x, and the y we substitute for w. We go over this, and we have the joint PDF of z and w given by this from 0 less than or equal to w less than or equal to y, which is z plus w over 5 less than, and 0 elsewhere. However, we are not interested in z and w. What is the question? What was the question? Z. I don't care about w. I know w had a pattern today. And then instead use the determinant, to use the Jacobian approach. Well, so w is just an intermediate step, and this gave me f of z and w. But I'm not interested in W, I'm only interested in Z, which is equal to 5x minus 1. So how to find this? By taking the marginal, right? So f z of z is the joint PDF of z and w after integrating w from minus infinity. Voilà. Following? It's the marginal. So I have two London variables. I have the PDF, the joint PDF. In order to find the PDF of one of them, I need to integrate over the other for minus infinity. This is typically marginal. Well, the 5 here. هذه عارف؟ هذه 5 هذه 5 belongs to this divided by the term. طبعا هنا الفرق بين الحل هذا بين اللي نسويه في الجوكيبيان اللي استخدمناه، الجوكيبيان هناك بالعكس، هناك دي the inverse دي z دي the inverse and because of that هناك we multiply by the Jacobian. You know we divide because we took the Jacobian of the direct function. واضح؟ زي ما كنا نسوي لما كان عندنا one function. So now we find the PDF by marginalizing, by taking the marginal. So basically, what do we have here? We need to find what W and Z relationship. So you can see that W equals Z plus W over 5, right? So simply you need to find what Z is. Z is equal to 4W. Because Z equal to 4W, you can draw a line here. Okay? And take the integration from in order to find the PDF of W, you need to find the PDF of Z, you need to integrate this from minus infinity with respect to W, right? However, you integrate with respect to W, it doesn't go from minus infinity. It goes from minus infinity, from 0 to Z equal. So the W equal Z over 4. So basically, W, you don't integrate from minus infinity to infinity. You integrate from 0 to this line, right? نستفيد لأنه أصلاً كل شيء يبدأ من الصفر. So basically, X and Y and hence W and Z and this all start from 0 because there is no minus infinity. But you don't integrate W from minus infinity to infinity. You integrate W from 1 to 1. شوف من وين لوين W؟ من 0 إلى this point. But what is this point? This point, when we write it, W equal this point, and simplified, we get Z equal 4W. So the limit of integration of W goes from 0 to Z over 4. Z over 4. هذا علاقة واضحة شباب؟ This point, it comes from this point, which comes from this point. So W goes from here to here. But what is this point? This point is equal to W equals to Z plus W over 5. Right? Which gives you, it goes until the W هذا. ليش كده صار اللون؟ أول ما نحسن. واقع ما مهم. طيب. I will use the color. المشكلة الأزرق يصير كله نفس اللون. Want to use another color. شيء فاقع شوي. Okay. So basically Z, this point here is equal to what? This is W until the integration. So integration of W goes from 0 to this point. But what is this point? This point is Z plus W over 5, right? Now multiplying by 5 will give you 5W equals Z plus 5 plus W. So bringing W here. This basically means that 4W equals Z, which is this until W equals Z over. Until you need to integrate until W equals this, right? You integrate here in order to find the margin. You integrate from minus infinity of the PDF. So the PDF for W goes from where to where? From 0 to this value of W. هذه قدام. من وين جبنا هذه؟ من وين جبنا هذه؟ هذه هي الفاليو حقت الاكس. Basically PDF اصلا goes from 0 less than W less than Y less than X. This is the value of X, in this function of X. Okay, so now if we know from where did we get this, we find the W value until which the integration should stop. So we integrate from 0 to where? To Z over 4, and here point, of the PDF after just opening up this. So
why do we name it something else than that?
هي Z. في الحال هنا انا كاتبها Z كده. هي نفس Z. So this is Z, huh? This is Z. This is equal to Z. Sometimes I write it like this. Now, so when we have part that is not function of W, and we have another part that is function of W, you move function of W to another, and you only integrate the function of W. We have a simple exponential, so this is the integral. And the rest is just direct substitution, and we end up with this here. واضح؟ لكن أسهل لك من otherwise. If you don't do this, it will be يعني basically معلش the way to do it is to use basically you find the CDF of Z, right? Which is probably that Z is this line, small z, which is equal to 5x minus y, this line equal to Z, and then you find the region of integration. So then you and then you differentiate. This is a simpler solution than the previous solution.
What would be the limit of that?
Z is already from 0 to infinity. After you integrate over W, Z goes from 0 to infinity.
إذا الأخطاء هذا شكل فايل. بعد ما شكل
يعني إلى الآخر is chapter 5 اللي هنا chapter 4 ما فاهم اللي ما هذا ما له علاقة بالكويز. This is just before we leave chapter 5. I thought to give you لأنه هذا الميثود ما تكلمنا عنها باليوم. I thought what we did is we did this. بس تتذكروا you can solve it using another approach. الابروتش شوية شكلها معقد اللي يسوونها عليه. Which is this one. نفس الإكزامبل هذا. You find the PDF of not Z, which is equal to the PDF. The probability that Z is this times small z. Now what is Z? 5x minus y, right? This times Z. Now you need to find the integration, the region of integration for this. زي ما سوينا هنا, and you integrate, and then you differentiate. You might find this approach easier. You might find the other approach easier. It's another approach. That's not it. To give you another way to use the Jacobian to solve a problem of this side.
Why do we define the value of the
Jacobian لازم يكون لك two functions, or two functions, three functions. Actually, two variables, at least two variables. You need to have a matrix. You can't have a determinant of a vector.
فعليب المارجنال أقول بالإيه المارجنال بالإيه
ما سوينا نحن جبنا المارجنال على طول.
احنا السكات
ما في هي ما هي مارجنال. احنا اضفنا يا شباب. We are not trying to find the marginal here. We are trying to find the PDF of Z. Z is a new random variable. Okay. المارجنال جت لأنه الجوكيبيان يعطيني the PDF of Z and this new intermediate random variable that I defined to use the Jacobian. Jacobian ما تقدر, you cannot use it using one random variable. لأن الشيء عندك vector ما له determinant. You need to have at least 2 by 2 or 2 by 3 or whatever to find the determinant. Okay? Right. Any question? So by this, basically, this is the last thing I need to say about chapter 5. Do you have any question? Please. Now we can leave this to chapter 6. as I mentioned, this has nothing to do with the quiz because you can say that this is part of chapter 4. No, this is just for you. طبعا داخل في اختبار عندنا لكن ما له علاقه بالكويز اللي جاي ولا حاجه. بس عشان تكون كلير. طيب. So now we are done with all the discussion about random variables. Now we need to move to chapter 6. Chapter 6 is not about random variables, it's a generalization of the random variables, which is called random process. Generalization of a random variable is a random process. Now, let me start with an example. So in this chapter, we'll talk about several topics. First of all, introduction, then talk about the random process. We define the joint distribution, independence, the concept of independence, the moments. We define new concepts about stationarity, correlation function, Gaussian as usual, random process. We will not talk about the Poisson random process. And we'll talk about the time averages and the measurement of correlation. So this is roughly the rest of topics. Now, before I go into the discussion, let me give you an example or two examples. One is sleep and one continuous stress, or is the idea of random process. And then we go into the formal definition of random process. Now, so far, until now, all our discussion was about having an experiment and looking at the outcome of the experiment, mapping into the real line, which basically gave us the concept of random variable, right? And if we have two experiments with two outcomes, we can have two random variables. So now, what about looking at the same experiment outcome, however, over time? Okay. Now, let me give you two examples, and hopefully these two examples will illustrate the idea. The first one is about GPA of students over semesters. So basically, let me say this. Now, suppose that I look at two students and I measure the GPA of, I take one student, student number 1, I measure his GPA. This is semester number 1, so semester 1. Term 1, term 2, term 3, okay, and so on. How many terms we have? 10 more. More. Student number 1, probably he starts not a very good student. His GPA is a little bit low. بعدين بيتحسن، يشد حلو، يبدا يشد حلو، يطلع ممتاز، يكمل وهكذا. This is one student, right? If I pick another student and I look at the progress of his GPA, again T1, T2, T3, T4, T5, probably he was the opposite. He was a good student, and then he started to play around. بدأ شوي يخبص، بعدين انتبه لنفسه، بدأ يتحسن. Okay, if I pick a third student, the GPA progress will be different. Probably the student is sometimes good, sometimes lousy. مرة ينتبه مرة يخبص، مرة ينتبه مرة واحد خامس رابع will be different, will be ممتاز طول الوقت. Okay, and so on. So now what I'm doing here is I'm looking not only, I'm making an experiment. The experiment evaluation outcome is the student. I'm picking the student. Okay? اليوم ما نبغى ايش كنا نشوف the GPA of the student. Here, we are looking at the progress of the GPA over time. So we are not talking about for every student a number. We are looking at for every student we have a function of time. Okay? So for every student number 1, I have a function of time. Student time, I have another function of time. Student time, I have a third function of time. In this case, this function of time is this key function of time. Okay? الآن, if I look at, so basically for every student, what is this? Is it random or not? This function of time. How can we start from it? For every statistic student, what is this? It's a statistic function of time. So it's not random. For this student, this is not random, it's a specific function. صح? However, if I look at a specific semester and I take a snapshot of all students at a specific semester, what do I get? I get a number for this student, another number for this student, صح? A third number for this student, fourth number for this student. If I have 100 students, I get 100 different numbers. These 100 different numbers constitute a random number. Low distribution, low average, low variance, and so on. So, if I look the random variable, sorry, at the second semester, I get another 100 numbers. 100 numbers will be also another random variable, will constitute another random variable. with a different average. ممكن الافريج هنا يكون مختلف عن الافريج. ممكن الاختبار اللي في الجامعه يكون اصعب السنه الترم هذا مقارنه بالترم هذا، او الدفعه هنا احسن من الدفعه هنا. So every time I look at one semester, only one term, I get a random value. If I look at another semester, I get another value. If I look at one student, I see a time function. Now, the collection of these time functions are called random functions. And the snapshot of one point in time across different outcomes of the experiment, I get random value. واضح شباب؟ So this will look like random variable. Okay, and this will look like another random variable. If I use another color, these two will look like another random variable, and so on. هذه كلها هذه نسميه time function أو نسميه realization أو نسميه sample function. كلها نفس الشيء. نفس الشيء هذا، نفس الشيء هذا، نفس الشيء هذا. Okay. كلهم كده مع بعض. Collection of these time functions of all these sample functions are called random process. So simply, the random process, every time you run the experiment, chapter 2 is like a number, an outcome of the random value. The outcome of the experiment is mapped into a real number, into a number. So every time you run the experiment, you select the student, you get the random value, a number. Here, every time you run the experiment, you get a time function. To the discrete or continuous definite array. And check the experiment. Here, you run it again, you select another student, you get another time function. Now, looking at one time instance, one semester in this case, the collection of these numbers, هذا ممكن يعطيك رقم، هذا يعطيك رقم، هذا يعطيك رقم، كأنه اختبار، كأنه the scores of students in an exam. نفس الشيء هذا كأنه random value. Low average, low distribution, ممكن يكون Gaussian، ممكن يكون هذا another random variable. It might have the same distribution, it might have different distribution, it might have the same mean, the same average, it might have. As we go over time, you end up with different random values. So here is the behind. Let's take another example about the continuous. In the continuous example, we talk about signals or a signal received at a point. Okay. Now, if you look at if you are at a certain location in this place, you are receiving the signal on the base station or the Wi-Fi or the internet. It goes through different reflections حسب الموقع الانترنت الموصل، حسب الريفلكشن اللي بتجيها تجيك سيجنال معينه، تيجي كده سيجنال شكلها طالع نازل. If you look at the oscilloscope, you will get a signal that looks like this. Now, if you change your location and repeat the same experiment, basically making the code and looking at the receipt signal over the oscilloscope, you will get signal شكلها مختلف. If you repeat the same experiment again, you will get كل مرة جربوها في اللاب كل مرة تلاقي signal شكلها مختلف. It's a random process. It's a random signal. تعتمد على where you are in the room and the reflections and so on. Now, every one of these are called زي ما قلنا sample functions, realization, high function. And if you zoom in at a specific time, T1, okay, لو تلاحظ at T1 you get this point, at T1 you get this, at T1 هنا إن شاء الله كلهم طلعوا نفس الكلام. At T1 here, this is not a good time. At T2 you get here, هذه T2. هنا at T2 يطلع لك أصغر شوي. At T2 هنا يطلع لك negative. At T2 هنا يطلع لك شوي positive and so on. So imagine you repeat the experiment 100 times or 1,000 times or 10 times. You have every time you look at specific time, you get collection of numbers which constitute a random variable. This is a random variable. هذا نسميه x of T1. هذا random variable called x of T2 and so on. هذا third T3. This is a third random variable that we call it x of T3. All these are random. Nice one. كل هذول random variables. x1, x2, x3, and so on. So how many random variables do you have here? Uncountable number of random variables. Here, how many random variables do you have? Consistent, not much, maximum. So here it's a discrete and limited. Here this is a continuous and even uncountable. Every random variable here is it discrete or continuous? If I look at the GPAs at one for all students at one semester, is it a discrete random variable or the continuous one? Discrete. Well, the continuous, that's right. GPA, continuous or discrete? You don't have a specific points where you can allow. You can have 2.54, you can have 2.55. So in general, it's continuous. However, the random process is discrete in time. لكن كل random variable من هذول is continuous. هنا clearly the signal is continuous. Every random variable here is continuous random variable. However, the time here is continuous. Okay. So it's very important to understand this concept. And the rest of this chapter is about how to describe this random variable. Sorry, random process. Okay. So how to describe it? Simply we need to find, in order to understand how this random process behaves, we need to understand العلاقة بين every collection of these random variables. كده احنا قلنا two random variables اللي اخذناها في chapter 5. Here we'll talk about many random variables. So ايش علاقة الرandom variables هذه ببعض؟ Will give us whether the signal here changes slowly or fast. إذا مثلا هذا highly correlated with هذا x of t1 is highly correlated with x of t2 معناها ايش؟ معناها السيجنال تمشي بطيء. بينما إذا ما في correlation means that signal changes at a fast rate. So we'll talk about how to describe the random process in terms of what we call joint distribution, joint PDF, joint CDF, and then we'll talk about what we call the autocorrelation function and different other functions. هنتكلم عن joint moments, joint distributions, joint PDFs and so on. لكن مهم جدا دائما نمشي تكون فاهمين الكونسبت. If you don't understand the concept, you will be lost in the rest of the course. لأن كل شيء هنتكلم عنه بعد كده will depend on the understanding of why at specific time we have a random variable and what does S here mean. Basically, it's the outcome of the experiment, and you will have for every outcome one sample function or one time function. unlike in the case of chapter 3, which is random variables. Now you can have another example, weather, okay? Yes, you can have some examples. Yeah, any question? Clear? Oh, clear. Thank you. And let's move into. So basically, what we'll do, as I mentioned, we'll now, until now we just defined it using examples. We'll formally define it now, and then we'll talk about the different relations between these random variables, joint distribution and density in moments, joint moments, and we'll talk about independence. And then we'll talk about stationarity. It's a concept that tells you whether the signal changes over time, every moment, and the correlation function. And then we'll focus mainly on the Gaussian random variable, and then we'll talk about aerodynamics. So, in order to formally define the random process, so here basically we have the same example that I did before. Every time you run the experiment, you get an outcome. S1, S2, S3. Consider it as a student, a location where you do measuring, a location for measuring the weather, whatever. And for every sample function, for every outcome, you get what we call a realization or a sample function. Right? This is a realization. This is a third realization. So this realization is a function of what is right? Function of time and function of outcome. This is a function of t and the outcome. If I change the outcome, I get another function. If I change S2, بدل S1 يعطيني function مختلف. If I change S3, I get a third function. If I change S4, I get a fourth function. This is the example I experienced. And for every S, I have a function that is a function of time. It's a function of time, it's a function of time, it's a function of time. Whether it's a continuous function of time or discrete. نسميها الرandom process أسماء مختلفة. لكن both of them, in both cases, it's a function. So we call every sample function, we donate it as x of t and the outcome, which is S1 here, S2 here, S3 here. All of them are functions. Now, if I look at the random process at T1, at this specific time, T1. Okay? Now I see a number here, I see a number here, I see a third number here, and so on. Now we call this as x of T1. It's a random variable that is happening at T1. At T2, we get x of T2. At T3, we get x of T3, and so on. Now, these are random, again, variables. And so on. Now, احنا قلنا هذا اسمه realization or sample function. Now, the collection of all these are called the ensemble, or they are the random process. كل هذه اسماء. Okay, so at fixed S, the graph of the function x of ts versus t for a specific S is called realization, ensemble member, sample function. كلها اسماء. The collection of these sample functions is given to be equal to or called the ensemble. And the collection, the set of all sample functions is called the ensemble. For every fixed t, x of tks is a random variable. Here S is not S1, S2, it's S. It's a function of t. Okay? I saw it. Why do we need to do this? Why are the processes important? Clearly, in electrical engineering, you deal with many signals. So signals at the end are variable because of the noise and the reflections that we just spoke about. So in order to be able to assess and analyze your signals, you need to be able to find how these signals behave. And you need to do this by the concept of random process. If you don't get the random process, you will not be able to analyze, design your systems and the randomness conditions. And everything is in real life is like you have something that is desired, you know it, a signal, cosine wave that you said, and you get an undesired signal, which is the noise. Or you get the signal with a random amplitude because it gets reflected from any place. Okay? So, you are clear? So, the random experiment, so consider a random experiment satisfied by an outcome S with some sample space over some sample space, and by the probabilities of these events. Suppose that for every outcome S belongs to capital S, this is the sample function space. We assign a function of time. For every S, we assign a number. We map every S into a number in the real line. Right? Here we assign every S a function. So إذا كان لي the random variable and the random variable domain. This is S, and we had S1, S2, right? And this is the real line with the color. S1 is mapped into X1, S2 is mapped into X2, and so on, right? This is what we used to do in the random variable. In the random process, the same S, we have S1, we have S2. Now, S1 is not mapped into a number, it's mapped into function. And S2 is mapped into another function. And so, third one is mapped into a third function. And so, okay. Again, if I zoom in into a specific time, this gives me, if this is T1, this gives me X T1. While if I zoom at specific time T2, I look at, will give me X of T2. The collection of numbers. Right? So what we did is we have created what we call an index family of random variables. X of T is where T belongs to certain set. Whether it's a real line, in a real line معناها it's a continuous random variable. It's if I is Z, this is a discrete. Okay, so if I here is R, you get continuous random variable. If I is Z, you get discrete random. Well, so this is a random process. Now the family of all these random variables is called the random process or stochastic process. In many books you will find it called stochastic or random. So by doing this, as I mentioned, we have family of random variables, X of P1, S, X of P2, S, X of P3, S, blah, blah, blah. Probably uncountable if it's continuous, or countable if it is not continuous, discrete. The collection of these random variables and the time functions gives you the random process, or the stochastic process. From now on, we will drop S. You will not find S anywhere else. And we know that this is part coming from the experiment. We run an experiment. Experiment can ma'ana you select the location and the signal, or select the location and the temperature and pressure and so on, the weather, or you select a student and look at his GPA, or select a student and look at his exams, whatever. So the experiment is underlying, we know that it's there, it's the source of randomness, but we will not repeat writing this. So we will drop this from all the discussion to come. But if we know that this is there. Questions? These prediction functions. هذه I'm just drawing it خلينا نقول in general. لكن الexample اللي مثلا gave you about the GPA, the function will be a series of impulses. هذه عبارة عن مثلا هذا الجي حق الطالب S1 في أول سمستر، ثاني سمستر، ثالث سمستر، هذا العكس وهكذا. And function is basically what when you select the student, you see that his GPA changes over time according to certain time. If you look at an S or explain as the weather, you look at the location. هنا في الطهران، في الخضار، عند الكورنيش، داخل شوية، different locations. The location will be the S, the outcome of the experiment. And the temperature over time, مثلا في نوفمبر أو طول السنة, you will find that the temperature will follow certain. طبعا يقول الظهران والخبر كلها نفس الشيء، لكن خلينا نقول لا، الظهران مثلا لندن وموسكو وسنغافورة different locations. هتلاقي ان الويذر مختلف. الويذر مثلا خلينا نقول if we plot it from January إلى ديسمبر، هو الظهران هتلاقيه يمشي مثلا جانيوري حيكون شوي منخفض الحرارة، بعدين يجي جون وجولاي كده ترتفع وبعدين تنزل، والرينج حقنا يكون مثلا من 10 إلى 50. بينما في تروح لموسكو لا، في جانيوري كان في ماينس 30، يوصل في الصيف إلى مثلا 20 ولا ما أدري كم، فتلاقيه مثلا هنا نازل تحت، بعدين يطلع فوق، بعدين يرجع ينزل تحت. صح؟ بينما في لندن لا، تلاقيه مثلا من ماينس 10 ماينس 5 إلى 30. ف different locations give you different time sample function. الفكرة هي كل كالتالي. Selecting the outcome gives you a function, time function rather than a number. الآن if I look at the weathers هذه, the weather locations, if I look at January and I look at the temperature in Dhahran, Moscow, London, Singapore, هتلاقي إن كل واحدة تعطيك رقم. Now this weather or temperature in different locations in January gives you a random number. No distribution, ممكن يكون Gaussian, ممكن يكون uniform, ممكن يكون low mean, low average, low variance. At June هيعطيك random value مختلف. المين هيكون أعلى، صح؟ الفاريانس ممكن يكون نفس الشيء، whatever. واضح الفكرة؟ But as we go on, we'll have probably more examples. إلى عندنا 3 examples. And hopefully it will be more clear. لكن شباب مهم جدا انكم تفهموا فكرة انه if I sample at a specific, if I look at the random at a specific time, I get a random value. الآن how would I quantify or at least analyze the signal here from the random process by looking at the relationship between these random values. ايش الjoint distribution of this with this method. The more I can collect information, the more insight, the more information you know about the environment. Okay? So,
what if there are noise that scares all this?
Yeah, to consider another one. You consider as cosine the carrier, A and T. Consider this as the noise component. Huh?
If I want to filter it and have one.
Chapter 7 8 يكون about filtering. نحن هنا in this chapter will only chapter 6 will be devoted only to look at the random process from time domain point of view. العلاقة بين الراندوم variable هذا والراندوم variable هذا and how can we describe it in time domain. In chapter 7 we'll do the same thing in frequency. So we will define حاجة اسمها power spectral density. ونتكلم عن علاقة يعني السيجنال هذا in time domain كشكلها في الدومين. Is it high bandwidth or small bandwidth? We'll talk about this in chapter 7. In chapter 8 will be about the filtering. How can I filter the signal? And if I input it into a linear time invariant system, what will be the output? Well, so chapter 6 will be only time domain analysis. Chapter 7 will be frequency domain analysis. Chapter 8 will be the filtering and the relationship in time domain and frequency domain between the input to an LTI and the output of the LTI system if the input is random process. I would say 3 weeks. After that, we are left with only part of the statistics and delay. The other instructors wanted to delay it. So. Okay, parameter shaping, and we're talking about in order to quantify the random process, we need to know the relationship. Huh? So you can see that chapter 5 and 6 and 4 are at the heart of what we're discussing. The correlation, the covariance, the independence between two random variables, the joint distribution. كل الconcepts الكلام عنها chapter 4 chapter 5, 6, chapter 4 and 5, chapter 5, we'll be talking about it every day almost in chapter 6, chapter 7. So if you have weakness in these things, in these concepts, please try to remediate because we are growing with the material and everything will be built upon what we have finished. Okay. Any questions? Right, classification of random variable of random processes. You can clearly see that since you have time and amplitude, you have discrete in time and continuous in time. You have discrete amplitude or continuous amplitude. So you can have 2 by 2 is how many classifications, 4, right? So you can either have a continuous time, continuous amplitude, which is the typical random process, signaling, or you can have a continuous amplitude discrete time, like for example, here, predicting the student and looking at the people, continuous amplitude, however discrete time. Or you can have a typical digital signal coming out of a telephone line, for example. You can see that you have the signal is random. However, the amplitudes are limited only to binary, plus or minus 5 volts. Okay, so this is the typical outcome of output of a digital system. So you have the signal is random. However, the amplitudes are only limited for 2 digits. Or you can have a discrete time, discrete alphabet random process. So the discrete alphabet random sequence. By the way, بس عشان ما أنسى, in discrete time we call them sequence. We call them processes, it's a random process, but specifically we call them a random sequence. So if I tell you it's a random sequence, means that it's a discrete time. So random sequence means discrete time. If I say random process, not necessarily. It's only discrete time, discrete or continuous time. Random process is the general term. Like when we say sequence, means it's a discrete time. So here it's a sequence, for example, and here it's a sequence. Okay, this is a discrete, discrete alphabet, discrete time, which is a random sequence, and you can see that now this is, for example, a sampled version of this. You can see that it's only defined at discrete times, and it has 2 amplitudes. Okay, so in general, you can have one of the 4 different classes of the random process. And so on. Class is almost finished. So next time, inshallah, we'll talk about more of this, and we'll have our quiz next Sunday.